My name is Galenbeck. In this short video, I will talk about the wave properties. But first, let's recap what a wave is. A wave is disturbance which carries energy from one place to another place without carrying matter. On the short animation, you can see a string which is disturbed from the left end, and the wave is traveling to the right. However, if you place a ruler next to the green particle, we can see that it's moving only up and down. So the particle is not being transferred. It's not moving to the right. It only oscillates. What is being transferred is energy. There are two types of waves, transverse and longitudinal. In a transverse wave, the direction of the disturbance is at right angles to the direction of travel of the wave. On the first video, you can see that the wave is moving to the right, and particles oscillate up and down. These types of waves are called transverse waves. On the second video, you can see that the wave is also traveling to the right, but now the particles oscillate right and left. When direction of the disturbance is parallel to the wave is called longitudinal wave. All sound waves are longitudinal. Any wave can be described by following 5 properties: wavelengths, frequency, speed, amplitude, and phase. Let's learn more about each of them. For this purpose, this graph will help us. The graph shows the displacement of the particles against its distance at a certain moment of time. Speaking simpler, this is a snapshot of a wave. The wavelength is the distance between successive crests. The crests are the peaks of the wave. You can see them in the wavelengths on the diagram. We use Greek letter lambda to represent the wavelengths. The unit of wavelengths is meter. The frequency is the number of complete waves generated per second. It is represented by letter F, and its units is hertz. For instance, the frequency of sound waves are from 20 Hz to 20,000 Hz. This means that air molecules vibrate at least 20 times a second when we speak. The higher the frequency means the higher is the pitch of the sound. The next property is the speed of the wave. The speed is the distance moved by a crest in 1 second of time. Note that we are not talking about a particle moving to the right. It is the speed with which the energy travels. The standard unit of speed is meters per second. It is important to note that the speed depends on the properties of the medium. For instance, you cannot make the sound travel faster in air. You can make it only if you change the medium where it propagates. And the next property of the wave is the amplitude. It is the height of a crest from the undisturbed position. You can see it labeled by letter A on the diagram. The unit of amplitude is meters. In a sound wave, the amplitude represents the loudness of the sound. The fifth property of the wave is phase. On the diagram, you can see points K, L, M, N and their velocities. Points K and M are moving in the same direction and with the same speed. In physics, we say they are in phase, whereas points K and L are out of phase or in opposite phase because they are moving in opposite directions. Now, let's see the relationship between some of these properties. On this slide, you can see 2 waves of different frequencies generated on the same string. One has a frequency of 1.5 Hz and the other has 3 Hz. We can notice that the wave that has lower frequency has longer wavelengths and vice versa. The higher frequency wave has shorter wavelengths. So we can conclude that there is inverse relationship between the frequency and the wavelengths. Moreover, there is an equation which connects them. The speed is equal to the product of the frequency and the wavelengths.